So this presentation is going to be all about fog. You're going to follow along on this worksheet and complete this as I go through the presentation.
So we've been talking about clouds, and we typically see clouds up there in the sky because that's where it's cold. And when water goes up into the air and it gets high enough, it gets cold enough to condense, stick together, and forms a cloud. We typically expect to see clouds up there. We don't usually see clouds down here on the ground because it's not cold enough down here for that water in the air to condense and form what we call a cloud. But today we're going to look at a special circumstance, and that's a cloud that forms near the surface of the ground. That particular type of cloud is called fog. Fog is a cloud that forms on or near the ground, and you can see the fog back there. Now remember, a cloud is formed when water in the air gets cold enough and condenses. Well, I'm in Georgia, where we have very humid air, we have lots of water in the air, but down here near the surface, you can see there is no cloud. It's not typically cold enough down here to make all that humidity, all that water stick together and form a cloud. But over here, I do have a cloud. The question is, what's different over here? The difference is that's the Chattahoochee River, and the Chattahoochee River is pretty cool. So the air over the Chattahoochee River is pretty cool. The water temperature in the Chattahoochee is typically in the upper 50s. Obviously here in July, it is in the upper 70s. It's much warmer typically out here. But all of this air out here has a lot of water in it. And when that air moves over the Chattahoochee River, it gets cold. And the water in our humid Georgia air sitting here over the Chattahoochee River becomes cold enough that the water condenses, sticks together, and forms a cloud. This particular cloud is called fog because it's near the surface of the ground.
So let's define what fog is. I've said it a couple times, but just make sure we have this in our notes. Fog is a cloud that forms on or near the ground. So what must happen in order for fog to form? Well, it's the same two things that must have been true for a cloud to form. One, you've got to have water in the air. You've got to have water that's in the air, because it's what a cloud is. It's a collection of water that we can see in the air. Two, we've got to have it cold enough to make the water stick together, or to make the water condense to the point that we can see it. So how is fog different from other clouds? Well, remember that typically other clouds form up here because that is where it is cold. How is fog different? Fog is different than a normal cloud because it forms near the ground. And that's not where we typically expect it to be cold enough for that condensation to occur. But there are some situations that can make condensation happen near the ground instead of way up in the sky where we would expect it. And that's what we're going to look at. We're going to describe the processes by which fog can form.
So back there is the Centennial practice field, and you notice we've got a cloud sitting over the field. Well, that cloud sitting on or near the ground is called fog. And what's happened here is that it was sunny yesterday. A lot of water evaporated, got into the air, but overnight it's gotten cool, and the water in the air is starting to condense, and it's doing it a lot right here because that's grass. And we know that grass and plants don't heat up. They tend to stay cooler. So that's where the little bit cooler area is that makes the water in the air condense and form fog. Now you'll notice up here, I'm only about 100 meters from where I just was at the practice field. You'll notice here over the parking lot, there is no fog. And the reason for that is this was concrete or asphalt. And it was sunny yesterday. So the concrete and the asphalt we know soaks up sunlight, and therefore it gets extra hot, stays extra warm. So it's not cool enough over the parking lot for the water in the air to condense and form fog.
So let's talk about how fog forms then in the situation that we just looked at. Well, first of all, we got water in the air that gets cold overnight. Now the air over the grass is even colder, so the water starts to stick together to the point that we can see it. That's fog. Now we don't get any fog over a parking lot because it's warm there. The parking lots stay warm because they soak up sunlight all day. So you're going to have fog that forms over areas that are a little bit cooler than others, like grass as opposed to concrete. Now, in our area, when would fog most likely form this way in our area? Well, remember that fog has to have air that is getting cold enough for the water to condense. So summertime, it stays pretty warm overnight. This is going to be something that we're going to see happening a lot more likely overnight in the fall, because that's when we start to get cool enough nights that all of that water in the air starts to condense. We also have nice warm days in the fall, which means a lot of water still evaporates, but then the temperature drops at night and it condenses and forms fog.
So now I'm in a location about a half a mile from where I was when I explained how fog formed. So we got our body of water, and you'll notice there's no fog here. Remember that fog forms when water in the air gets cold enough to stick together, condense, and form a cloud. It happens near the surface when the water is cool and makes the air cool. Well, this water here must not be cool because the air over it is not cold enough to make my nice, wet, muggy Georgia air stick together and form a cloud. This is Big Creek. The difference between Big Creek and the Chattahoochee River is that Big Creek is pretty warm. It's basically the air temperature, because the Chattahoochee River comes out of Lake Lanier, which is formed by a dam, and it's a couple hundred feet deep, so the water at the bottom of Lake Lanier is very, very cold, hence the Chattahoochee River is very cold. Big Creek is not cold at all. So when my warm, wet, moist Georgia air comes down here and sits over Big Creek, it doesn't get cold. Therefore, the water in the air doesn't condense and form fog. Over there is where Big Creek dumps into the Chattahoochee River. The Chattahoochee River is cold, so the air over the Chattahoochee River is cold. And there, when my air from Georgia and my nice, hot, muggy, wet air sits over the Chattahoochee River, the water in that air gets cold, condenses, sticks together, and forms a cloud. So once again, one of the key ways in which fog forms is you have cold water with warm, muggy, wet air, which is typically what we have over the Chattahoochee River in Georgia in the summertime.
So here's the situation that gives us fog over the Chattahoochee River in the summertime. We have warm, wet air. It's humid air like we have in Georgia all summer. Well, when that warm, wet air moves over cold water, that air gets cold and the water in the air gets cold and it condenses and it forms fog. Here you see the Chattahoochee River. This was on out the window of a plane, and you look down, you can see right where the Chattahoochee River is. That's where the cold water is, because that's making the air cold enough to make the water in the air condense and form a cloud. Now, there's just as much water in the air over here and over here and over here, but the land is hot, whereas the river is cold, so you don't get fog except over the river where the air is cold. So notice in this picture, here's the Chattahoochee River, and there's no fog in this picture. Why not? Well, one of the clues is if you look here, look at the trees, they're not green. This is winter time. So in wintertime, the air here is cooler or it's colder, and it's not holding as much water. It's closer to the same temperature as the river. So therefore, you don't have the water content and you don't have the difference in temperature to make the water condense and form a cloud. So what time of year would you be least likely to see fog over the Chattahoochee? That would be winter. When would you be most likely? That would be summer. As a matter of fact, the Chattahoochee River almost every summer morning has fog over it. and it rarely has fog over it in the winter.
So let's talk about the formation of fog. Just a reminder what fog is. Fog is a cloud that forms on or near the ground. Well, what's a cloud? Remember that a cloud is just a visible collection of water that you can see in the air. Well, what makes a cloud is when water in the air gets cold and it starts to condense so it sticks together so that we can then see it. Clouds usually form way up there because that's where it's cold and water is likely to condense and start to stick together where we can see it. But sometimes we get a situation like this where we can see water in the air on or near the ground. That's fog. Well, there's a couple ways in which fog can form, and behind me you're going to see an example of one of the methods that causes fog to form. It is now November. It is starting to get cold outside. The air this morning is in the upper 30s, pretty chilly. But the lake, which is water, doesn't heat up and cool down as easily as the air does. So it's November, it's been nice and sunny. We're in the south in Georgia where we get a lot of sunlight. So the lake water has not cooled down that much. It's still pretty warm. Because it's pretty warm, it's evaporating pretty easily. But we have this cold air mass that came in from Canada. So when the warm water evaporates into the cold air, it immediately gets cold enough to condense so that we can see it. And we've got a cloud over the surface of this lake, and that's what fog is. So once again, one of the methods in which fog can form is when you have cold air sitting on top of warm water.
So that's represented by this diagram here. 1, 2, 3. What's going on here? Well, one is we have warm or hot water. I'm going to say hot, but you can see warm, and it's evaporating. The second thing that has to be true is we got to have some cold air come in. So we get some cold air that moves over the hot water. Well, the cold air then makes that evaporated water condense, stick together, and form fog right over the water source.
All right, now here I am in the same spot, but it's later in the day. It's about 12 o'clock. So the sun's been up, and notice that my cloud or my fog is gone. And what's happened here is now that the sun's come out and the temperature has gotten higher, all of that water that was cold enough to condense into a cloud that we can see has now gotten hot and re-evaporated back up into the sky. If I come back out here tomorrow morning, I might see the cloud out there again.
So what happens to fog later in the day, and why does this happen? Now here's two pictures right here in our area. We've got Kohl's over here across the street, and we've got the same day looking up the street, there's the parking lot out in front of the school. And this was taken fairly early in the morning. You can see we got some fog. But what happens just a few hours later is the fog is gone. And what's happened is the sun has come out and has given the water the energy to evaporate again. So to answer our question, what tends to happen to fog later in the day? It tends to evaporate. It tends to disappear. Why? Because it's getting energy from the sun, which allows it to evaporate again. Now, we come out to this same spot tomorrow morning, we might see the fog again, because overnight it's going to get cool, take away the energy, and we might get this process happening again. Now, valley fog. We tend to see fog forming in the valleys as opposed to the tops of mountains. And let's look at why. Here we can actually see it. We can actually see the fog down. This isn't a case where we've got a river down there with cold water in it. This is a case where the fog only formed at the bottom of the mountains. Well, what happened overnight was the sun went down, the air got cold, and the air slid back down the mountain. Remember, we talked about those valley breezes, where once the sun goes down, the air slides back down into the valley. So we wind up with a little bit more air in the valley, which we wind up with a little bit higher amount of water in the air in the valley. Well, the sun goes down, got a lot of water sitting in the air in those valleys, and the water gets cold, condenses, starts to stick together, and we see clouds. It's near the ground, so we call it fog. Now, what time of day do you think this happened? This picture was taken first thing in the morning. Once again, this is out the airplane. This was flying over eastern Australia. If I had taken this same flight a little bit later in the day, I wouldn't have seen this, because by then the sun would have made all of that water evaporate again. So here's our steps in the formation of valley fog. First of all, the air gets cold at night, especially at the tops of the mountains, and then it slides into the valley. Well, when there's enough water in the valley and it's cool like it is overnight, it starts to stick together. We can see it. That's what fog is. This is a special type of fog called valley fog. When is fog most likely to form this way? That's going to be overnight, because that's what causes the water to go into the valley in the first place. You're going to see valley fog overnight or first thing in the morning.
So out there's the Pacific Ocean, and there's a breeze coming off the Pacific Ocean, and of course it's picking up water that evaporates from the ocean. Well, when the water in the air hits these mountains right along the coast and it's got to go up, it's a little bit cooler up here, so that water condenses and it forms a cloud. This particular kind of cloud is what we call a fog, because it is a cloud that is forming close to the ground, and you can see where the water is coming from. And the reason why it's forming the cloud here is because it is cold enough now that it's high enough up and the water gets squeezed together, forms a cloud. On the other side of this hill, and the air starts to go back downhill, it starts to warm up, the water evaporates again, and it's actually sunny on the other side of this hill.
So here you can see the fog coming over the top of the hill. You can see that sea breeze coming on shore, and it's bringing the air up and over the top of the mountain. This is where it's coldest, and you can actually see the fog. But now the air starts to go down the hill on the other side. It starts to warm up. The water evaporates, and you can see it's sunny over here, because on that other side of the hill, it's now warm enough and the water can't stay condensed, and hence no fog on the other side. This is what we call upslope or mountain fog. So we can get fog in the valleys, and we can also get fog forming on the upslope, or as the air goes up mountains. And let's take a look at how that forms. First of all, you got air with the water in it that moves up the mountain. And we know what happens as you go uphill. It gets colder. So the air gets cold as it goes up the mountain, which means the water in the air gets cold as it goes up the mountain. Well, if it gets to a point that the water in the air gets cold enough, it's going to condense. It's going to stick together to the point that we can see it. That's what a cloud is, or in this case, it's what fog is, because it's close to the surface of the ground. This is what we call upslope or mountain fog. So that's the end of the presentation on fog. You're now going to take your notes check that covers clouds and fog together.